One-on-one, bitch, they 10. One-on-one, never again. One-on-one, won't get the kick in the butter. I kinda like hustle.
I really don't want to drive over the hill right now.
Yeah, me neither. What times can you go?
I can go from 12 p.m. to 12 a.m.
I wonder when there's the least amount of cars on the road.
Yeah.
I wonder if we could use calculus to figure this out.
Oh, we definitely could. We should try. Let's try.
To represent this problem, we need an equation that tells us how many cars are on 17 at a certain time, the time being t. For our equation, we chose to use sine because the curve of sine mimics the flow of traffic, and then for the rest of the equation, we messed around on decimals till we found something accurate. And then our domain for it's going to be 12 to 24, which is 12 p.m. to 12 a.m.
The derivative of f of t will tell us when f of t is increasing or decreasing and when peak traffic is. To start, we need to use the product rule. We did low, our sine function, times d high, which is 0 because 700 is a constant. Then we added high, 700, times our derivative of our sine function. To find the derivative of the sine function, we need to use the chain rule, so sine becomes cosine and we keep the insides. Then to find the derivative of the inside function, we use the product rule. The derivative of 1300 is simply 0. Then we simplified to get f prime of t.
By finding when f prime of t equals 0, the extrema will help us determine when f of t is increasing or decreasing. F prime of t equals 0 when cosine pi over 15 times t minus 9.5 equals 0, and cosine x equals 0 when x is pi over 2 or 3 pi over 2. We set our cosine function equal to pi over 2, which is also 7.5 pi over 2 because we are multiplying it by pi over 15. So t minus 9.5 equals 7.5. Then we added 9.5 to both sides, getting that when t equals 17, our cosine function is equal to pi over 2. Thus, it's equal to 0. We did the same thing to find when our cosine function equals 3 pi over 2, which is also 26.5 pi over 2 because we're multiplying it by pi over 15. We set t minus 9.5 equal to 26.5. Then we added 9.5 to both sides, getting that when t equals 36, our cosine function is equal to 3 pi over 2. Thus, it's also equal to 0.
Using the first derivative test, we can see when f of t is increasing or decreasing. So we tested it on a number line. By plugging in 15 to f prime of t, we can see that it is positive, and by plugging in 20, we can see that it is negative. Then we know that from 12 to 17, our function is increasing because f prime of t is greater than 0, and on 17 to 24, our function is decreasing because f prime of t is less than 0.
By finding f double prime of t and setting it equal to 0, we can test for concavity on f of t. To start, we need to use the quotient rule. We did low, 3, times d high. To find d high, we need to use the chain rule, changing cosine to negative sign, keeping the insides the same, then multiplied it by the derivative of the insides, which requires us to use the product rule. We then subtracted our high times our low, which is simply 0, and divided the whole thing by low squared, which is 3 squared. Then we simplified to get f double prime of t.
To test for concavity, we need to set f double prime of t equal to 0. F double prime of t equals 0 when our sine function equals 0. Sine of x equals 0 when x is pi or 2 pi. We set our inside function equal to pi, then got that t minus 9.5 equals 15. Added 9.5 to both sides, getting that when t equals 24.5, f double prime of t equals 0. Then we did the same thing for finding when our sine function equals 2 pi. We set it equal to 2 pi, then got that t minus 9.5 equals 30, added 9.5 to both sides, getting that when t equals 39.5, f double prime of t equals 0.
We can test our extrema, t equals 17, from the first derivative test, and our endpoints for the concavity. By plugging in 10 to f double prime of t, we see that it is positive. For 15, it is negative, for 20, it is negative, and for 30, it is positive. Since f double prime of t is negative on 12 to 24, we know that f of t is concave down on this interval. And since the concavity changes at 12 and 24, these points are points of inflection.
To help us curve sketch, we need to find f of 12, f of 17, and f of 24. We got that f of 12 equals 1,650, f of 17 equals 2,000, and f of 24 equals 1,370.
Now we can use all this information to sketch a curve for the traffic on Highway 17. We started by plotting our points, 12, 1,650, 17, 2,000, and 24, 1,370. Then we knew it was concave down because f double prime was less than 0, and that it was increasing from 12 to 17 and decreasing from 17 to 24. We know that 17 is our max because f prime of x goes from positive to negative, and that 12 and 24 are our points of inflection because the concavity changes.
So guys, I wonder what time we should go based off our graph.
Well, since our graph is concave down and our max is at 5, we definitely shouldn't go at 5 p.m.
Yeah, I
Yeah.
agree with that.
I vote we either go at 12 p.m. or 12 a.m. 12 a.m. is a little bit lower, less traffic if you don't mind driving late.
Let's go at 12 a.m.
Let's go.
Let's go.
One-on-one, bitch, they 10. One-on-one, never again. One-on-one, won't get the kicking.